Continuing with the energy coming in and energy going out, I also have to mention the sound coming in and the sound going out. As I mentioned before, I'm in Mumbai. It's middle of May. It's very hot and very humid, and I'm living without an AC. So I have to leave my window open and I have to run a fan. The fan makes some hissing sound, but in the previous podcast I saw a strong hissing sound in the background. I listened to it. It's fairly okay. Sound is okay, especially if you listen with earphones. But there was a some kind of an insect that started making loud sound outside the window. I'm sitting here, there is a window here, and maybe you can see that there is vegetation here, very nice mango trees and so on, but that also brings a lot of sound. So sorry for the sound. You let your parents or elders listen to it and send me a message. If the recording is really poor, then I will try to redo it. Okay, so let's come back to energy balance that we talked about. Shortwave energy coming in, long wave energy going out, and we said we do it for all of Earth just to simplify life, but we also said the albedo is not the same everywhere, and there are winds, as you know, and the energy moves from the ocean to land, land to ocean, from low latitudes to high latitudes. Remember, low latitudes are getting more energy from the sun than they are sending back to space as thermal energy, and higher latitudes are getting less energy from the sun than they are sending out to space as thermal energy. So they have a constant deficit, or they are constantly losing energy at higher latitudes. They are constantly gaining energy at lower latitudes. So it's like saying you are I don't know what analogy to use. Let's say you are making more money than you can spend, and you have a brother or sister who is making less money than they need. Then, to prevent the brother or sister from getting poorer and poorer, you can keep giving some money to the brother or sister to balance their budget. So, to prevent the poles from getting colder and colder and colder and colder, and the low latitudes from getting warmer and warmer and warmer, we are constantly moving energy from the low latitudes to high latitudes. On the mean, of course, low latitudes are warmer than high latitudes, but they're not getting colder here and they're not getting warmer here. They get warm in the summer and cool again, and they get cold in the winter and a little bit warm again, and so on. So there are winds, which means any budget we do also has to see how the energy is distributed, how the temperatures are created, let's say at the surface. This is like saying parents make the money, they give it to all the kids, and they have to track how the money is being spent, right? So for various reasons, you will see that depending on the albedo, on the convection, and how the energy is moving because of the winds and so on, there are regions where there is more energy being trapped, or in a given year, let's say this is saying 2023, the year 2023 had much warmer than normal temperatures here over the Middle East and the Mediterranean region, or the Arctic region, parts of Canada and North America, and here parts of the Pacific and parts of Southern Ocean and the Atlantic and so on. I hope the geography is something you know, or you can Google and find out, right? You already recognize the continents, I'm sure. Asia and Australia, Africa, North America, South America, and Greenland, Arctic here, and Antarctic here, and so on. We'll look at the winds a little bit later, but just imagine that there are winds which are moving the energy around. So when you do the global average, it doesn't matter whether the money is with you or your brother, or it's in Africa or Asia, it all gets averaged. But when you open it up and see who's getting what and who's spending what, this is what you will see. So you have to just remember that global warming doesn't mean it's warming everywhere. It's warming more somewhere and less somewhere. These white regions and blue regions are where temperature is in fact cooling, and you can see that parts of India here are colder than normal. What is this showing? This is showing what is called a temperature anomaly for year 2023 compared to years before. If you take all the years before and make an average of yearly average temperature at each location, then year 2023 was warmer than all previous years here, cooler than previous years here, cooler here, and so on. Why is this important? Because when we talk about global warming, we do average over all the planet again. So this is showing temperature anomalies again, which means the deviation from the normal. We already talked about this. Let's say today is May 20th. In May 20th in Mumbai, you expect hot, humid temperatures, but on May 20th this year is warmer than what you would expect every May 20th because of various reasons. That means it's anomalously warm. If it is cooler, then it would be cooler than normal. So when we say anomalies, that's what we mean. Is it as expected, or is it warmer than expected, or is it colder than expected? Okay, so using various methods, we have temperature information going back to 1850, approximately just after the Industrial Revolution started. If you don't know what is Industrial Revolution, you can ask your elders or teacher, or you can Google if you're old enough to do that. So you are looking at the anomalies starting in year 1850 through 2023, and this blue line here that is going up and down shows that some years were warmer than normal, some years were colder than normal. So you can see here 2023 is much warmer than normal. If you average all the temperatures on the globe, year 2023 was much warmer than normal. Why do temperatures go up and down from year to year? We said May 20th this year is warmer than other May 20ths in the past. Similarly, May this year may be warmer than other Mays in the previous years. 2023 was warmer than other years, right? So anomalies above expected, below expected can be for a day, for a week, for a month, for a season, for a year, and so on. So if energy is coming in and energy is going out every year, then why are some years warmer than expected and some years colder than expected? For that, you have to again think of the budget. Is energy coming in and going out every year the same way? Or are there places where energy coming in can be kept somewhere and not sent as thermal energy that year? Or are there places which are releasing more energy than they are receiving? So on a global average, energy coming in from the sun, we said, goes into evaporation, convection, heating things, and produces thermal energy. But remember the ocean. Ocean has a high heat capacity, which means if you start warming it, it will warm slowly and cool slowly. Go back again to the pot on the stove. When you start heating the pot which is made of metal starts heating fast because it has low heat capacity, but the liquid inside, water or whatever else, milk, will warm slowly, and when you turn off the fire, the pot tends to cool down much faster than the water inside. So ocean, which is also several kilometers deep, can take the energy, doesn't necessarily release it back as thermal energy the same year. It may keep it for many years, or it may release it next year. So there are reasons why energy is not balanced every year. incoming energy is not equal to outgoing energy every year. So temperatures can get colder than expected on some year, warmer than expected in some year. What is important? You want to see if each year is warmer than before. Is each year getting warmer than expected? So this red line is basically saying that even though years can be still warmer or colder than expected, we are now moving in one direction. So each year is more likely to be warmer than expected, and this is continuing, which means we are keeping more and more energy from the sun trapped in the system, either as water vapor and temperature in the atmosphere, or temperature and heat in the ocean. This is what we call global warming, because it's the global temperature, global average temperature that we are talking about. Okay? If you understand, it's very good. If not, please ask a teacher or ask me questions, send me comments and so on. But I hope you get some intuitive sense of what we mean. As we said, if we don't spend all the money, we keep accumulating more and more money. But if we keep more and more energy, we keep accumulating, we keep warming and warming. Okay, so we are increasingly warming because we are increasing the greenhouse gases, which are keeping more of the energy, which means the incoming solar energy at the top of the atmosphere is now not equal to the outgoing energy, thermal energy. So there is a saving of energy, which is warming the temperatures. Okay, so here is how it's happening. Again, this is got some numbers, don't worry. This is called Earth's energy imbalance. So the budget is not balanced. We are not sending all the energy back to space. We are keeping the energy, so the energy is not balanced at the top of the atmosphere. Why do we look at the top of the atmosphere? Because that's what determines how much energy is in the system. If everything that is coming in is going out, then we know that the system is distributing energy, but it's balancing it. But if it is sending less than what is coming in at the top, then it is not only distributing it, but it is keeping more and more inside. So Earth's energy imbalance results from increases in greenhouse gases absorbing thermal radiation that would otherwise be emitted to space. It would go out to space and dissipate outside. Okay, this radiative forcing, radiation is energy that is moving in light and wavelengths. This radiative forcing, which means it's forcing the climate and weather, this radiative forcing leads to an accumulation of energy in the Earth system. So the balance doesn't happen, there is an imbalance. So incoming solar radiation, again, some of that energy is going to melting the glaciers on Greenland and Antarctica, in the Himalayas and other mountains. Ocean is taking up lots of that energy, which is a good thing, because ocean is deep, has high heat capacity. It can keep on accumulating that energy and keep it. But what does that mean? That means atmosphere is warming, but it's not warming as fast as it can if ocean didn't take all the energy. Okay, I hope you understood. The energy coming in is being trapped and more is being retained or accumulating in the system, but it's accumulating in the ocean, which we don't feel immediately in the atmosphere. Okay, so it's like your parents are saving money, but they are putting it in a bank, so you don't get to spend it immediately. You will probably get it in the future for your college and so on. Is this a good thing? Well, it's good in the sense that atmosphere is not warming as fast, but ocean is warming. There are living things in the ocean. There is oxygen in the ocean, right? What happens to those living things and oxygen in the ocean? That's important. So there is outgoing radiation. Cloud changes are important to determine how the balance happens, because clouds can reflect energy or they can also trap the thermal energy. And if 100% of the energy is being, if the trapped additional energy is 100%. 91% is in the ocean, 3% is going in melting glaciers, only 1% is remaining in the atmosphere. Even though we are worried about global warming, atmosphere is warming with only 1% of the additional energy being accumulated, and land is taking up 5%. So the contribution to the increase in Earth's energy inventory is shown here as percentages. So Earth's energy budget encompasses major energy flows of relevance for the climate system. What do we mean by that? If we have warm temperatures here and cold temperatures here, if you don't understand this, don't worry. There will be pressure differences as well. Warm regions tend to have low pressures. Cold regions tend to have high pressures. Winds tend to go from high pressure to low pressure, and that means energy can move, okay, in every direction, in this direction, that direction, and so on. So energy is constantly being redistributed even as it is accumulating in the system. So as energy is accumulating, it is causing global warming. So average warming gives you a sense of how much additional energy is being trapped. Okay, that's why we look at global warming. Even though locally India may be cooling, Middle East may be warming, winds may be born because of these differences and so on. Okay, so these are we only discussed few concepts in this section, in this chapter, on greenhouse effect and greenhouse gases and energy balance and energy budget and energy imbalance and so on, but these are very important concepts, so you should listen and make sure that you understood, and you can sit and sketch these things to make sure you understand it. You sketch for yourself without listening to the podcast or looking at the books or figures. You draw the sun's energy coming in, how it is reflecting and how it is reaching the surface, how its thermal energy is being how the thermal energy is being produced, how much is escaping to space, and so on and so forth. Okay, very important concepts, but important to make sure that you really understand them. Okay, otherwise ask questions, send comments. Okay, so we'll meet in the next section and talk more about weather and climate. Okay.